AOPS Volume 1, the basics, number 18. Which are true? Conjugate of z1 plus z2 is equal to the conjugate of z1 plus conjugate of z2. Conjugate of z1 times z2 is equal to the conjugate of z1 times conjugate of z2. Or the conjugate of z1 divided by conjugate of z2 is equal to the conjugate of z1 divided by the conjugate of z2. Well, to solve this, we're going to assign z1 and z2, which represent complex numbers, an assignment such as a plus bi, and for z2, c plus di. A, b, and c, d are all inputs. They could be any number or integer. And for a conjugate, well, what is a conjugate? A conjugate is basically the changing of the symbol from the imaginary term of the complex number. So in a plus bi, the conjugate would be a minus bi. C plus di's conjugate would be c minus di. Notice how it changed the symbol from the imaginary terms into positive to negative. Now we're ready to start with the first one, the conjugate of z1 plus z2. By definition, we can apply the values for z1 and z2 to be a plus bi plus c plus di, which is equal to the conjugate of a plus c plus parentheses b plus di. I assorted the imaginary and real numbers together. If we take the conjugate of this becomes a plus c minus bi minus di. We can rearrange this to get a minus bi plus c minus di. Notice how a minus bi is the definition for z1's conjugate, and c minus di is the definition for z2's conjugate. Therefore, we've proved the first one as true. And what about the multiplication division? Well, that is the same process and application of the definitions for z1 and z2. And for the multiplication of the conjugates, let us first evaluate the conjugate of the two separately. So the conjugate of z1 is a minus bi, the conjugate of z2 is c minus di. So if we write that in, it's a minus bi times c minus di. And we can expand it if we want. So this becomes ac minus adi minus bci plus bdi squared. And ac minus parentheses ad plus bci minus bd will be its expanded and complete expanded form. And if I just rewrite this to group the real and imaginary numbers together, this becomes ac minus bd parentheses minus ad plus bci. I parenthesized to show you the real terms and the imaginary terms. So this is the completely simplified version of z1 conjugate times z2 conjugate. So what about the together, z1 times z2 conjugate? Well, we can apply the definitions to get a plus bi times c plus di conjugate. We can expand it to get the conjugate of ac plus parentheses ad plus bci minus bd. And what we can now do is we can group the real and imaginary numbers together, so we can take the conjugate of it. This becomes the conjugate of ac minus bd parentheses plus ad plus bci. And now we can take the conjugate of this term, which is equal to parentheses ac minus bd minus parentheses ad plus bci. Notice how the evaluated form of the conjugate of z1 times z2 and conjugate of z1 times conjugate of z2 are all the same to one another. Therefore, the second criteria also checks out. So what about the third one? Well, the third one is the same process for which we did for the multiplication, except now it's division. So if we first evaluate them separately, z1 conjugate divided by z2 conjugate, we know that z1 conjugate is a minus bi, z2 conjugate is c minus di. So this becomes a minus bi divided by c minus di. And if we wanted to simplify this further, we can get rid of the imaginary term within the denominator by multiplying both sides by c plus di over c plus di. So this becomes c squared plus d squared. Remember, I squared is negative 1. And the numerator becomes a minus bi times c plus di. And we can further evaluate this by expanding it. So this becomes ac plus parentheses ad minus bci minus bd times I squared, which is plus bd. And just checking my arithmetic here, and yep, it's correct. So now we can divide that by c squared plus d squared. We can group the imaginary and real numbers together to get a completely simplified form of ac plus bd plus ad minus bci divided by c squared plus d squared. So this is the evaluated form of the conjugate of the two z1 and z2 separately. So what about the conjugate of the two together? Well, the conjugate of them together, so z1 divided by z2, will be equal to the conjugate of a plus bi divided by c plus di. And we can evaluate this because we know that we can get rid of the denominator with the imaginary term. So this becomes a plus bi times c minus di over c squared plus d squared. I multiply both sides by c minus di to relate it to the form a plus b times a minus b. And this then evaluated will be equal to, if we put the conjugate symbol on top, ac minus parentheses ad minus bci plus bd. And I just simplified it and grouped some terms together. And this whole thing is divided by c squared plus d squared. And this then becomes, if we group the real and imaginary terms together, ac plus bd parenthesized, this is the real term, minus the imaginary term, ad minus bci, divided by c squared plus d squared. And the conjugate of c squared plus d squared isn't equal to anything because within the denominator there's no more imaginary terms. So we cannot take the conjugate of the denominator, but we can take the conjugate of the numerator because there is an imaginary term. So the numerator becomes ac plus bd plus adi plus bci. Sorry. That's it's supposed to be minus bci divided by c squared plus d squared. And I can group them together. To be further equal to, in its simplified form, c squared plus d squared in the denominator. And in the numerator, we would have parentheses ac plus bd plus parentheses ad minus bci. And notice how I'll circle in red because it's getting a little bit messy, that this term right here is equal to the expanded form of z1 conjugate divided by z2 conjugate. These two terms are also equal to one another, therefore proving that our third and final criteria is also true. So we have proved that all these three are true, and number 18.